Let's write a program. I'm going to show you how to write a very simple program. When you run it, it does nothing more than display a single line of text. No windows, no prompts for input, nothing, just a single line of text. Now, if you've elected to use an IDE, you can use the work area provided by the IDE to store your source code, or you can use the IDE controls to create a work area of your own. In either case, you'll need to use the text editor built into the IDE to create a file that contains the text of the source of the program. If you have elected to work from the command line, as I have done, you will need to create a work area by creating a new directory. You can call this directory anything you would like. I call mine JWork. I make it a current directory by switching to it like this. Now I'm ready to create the source file. You can use Edit, Notepad, TextPad, or any other editor you'd like. I'm going to use my favorite editor like this. Now, this is to be the source file of the Java program, so it must have the four-letter extension JAVA. The name of the file must be the same as the name of the class it's going to contain, and the upper lowercase letters are important. As far as Java is concerned, there are 52 letters in the alphabet, 26 little ones and 26 big ones. This is more important to some operating systems than it is to others, but it is always important to Java. We begin by defining the class to hold our code. The keyword class is used to specify that we are defining a class. The name of the class itself is spelled exactly the same way as the name of the file. Notice the uppercase H. If we were to use a lowercase h instead, Java would consider it to be a different name and not be able to locate it. This naming convention may sound a little restrictive at first, but later I'll be coming back to some of the reasons why it's this way, and you'll see that it does make things a little easier to work with. Notice the opening brace here at the end of the class declaration. Everything following this brace and coming before the closing brace that I'll put at the end is included in the body of the class. All Java programs begin execution with a method named main, so that must be declared first, like this. Declaring this method as public means that it is accessible from outside the class. That must be done to main, so the Java virtual machine will find it when it looks for it to start the program running. Declaring the method as static means that the method exists as part of the class definition in a form that is ready to be executed. If you don't declare a method as static, it's available only from inside objects made from the class, and we'll be getting to objects later on, and this will make more sense. The methods of Java return a value to their caller, and it's required that you declare the type of data that's being returned. If it happens, as in this case, that no value is to be returned to whoever calls the method, then it's necessary to declare the method as void to make that clear. Java is very picky about the types of return values. When you run a program, it's often possible to include options and other parameters on the command line. The string array named arg, you could actually name it anything you like, is where these command line parameters appear inside the program. I'll be showing you how this works shortly. Here's an interesting thing. A bit of an argument broke out during the original design of Java about arrays. Some said that the brackets should go on the name declaration as they are done here. Others said it should go on the type declaration here. What they did is they set it up so that you could do it either way you want. Pick one and do it. I haven't decided which way I like best, so sometimes I do it one way and sometimes I do it another. The only thing we want main to do is display a line of text, and that can be done with the following statement. The system class contains an object named out that has a print line method. This is an L, has a print line method that prints a line of text. All that's left to do is end the main method with a closing brace like this. This brace then matches this brace. The brace at the end, which matches the opening brace, which declares the end of the body of the class. And now it is a complete working program. All that's left to do is compile it and run it. Let's compile the Howdy program and see if we can make it run. If you're using an IDE, you'll find that you have a compile or a compile and run command somewhere on a menu or on a toolbar. If you're working from the command line, you'll need to invoke the compiler by name. In the working directory, you should have the file named howdy.java, which you can verify with the dir command. The name of the compiler is Java C. Notice the name of the compiler is Java, ending with the letter C, which I've always assumed is short for Java compiler. You should follow the compiler command with the name of the program being compiled like this. If you have not included any errors in your program, the compiler will create the class file when you hit the Enter key. If you get some sort of error message, it means that something is wrong in the text of your source file, and you need to go back and take a look at it. If you get no message whatsoever, it means the compiler succeeded in creating a class file, and you can verify this with the dir command. This class file contains exactly the same set of commands as the original source file, except it has been translated into bytecodes that can be understood by the Java virtual machine. The JVM should be able to load the class file and execute the commands it finds in there. The Java virtual machine is named Java, and you can run it this way. Notice this time that you don't specify the entire file name by specifying the class suffix. The JVM will add the correct suffix onto the file name that you specify. And that's it. That's all there is to compiling and running a Java program. Every program that we'll be writing in the rest of this course will be compiled and run in exactly the same way. You do have some command line options both on the compiler and on the JVM, and you can get a quick look at them by entering the commands without arguments. For example, to see the compiler options, enter the command like this. You don't need these options very often, but I will be showing you how some of them can come in handy for special situations later on, after you know a little bit more about Java. The JVM also has some options. In fact, it has more than the compiler, and they will scroll off the screen unless you stop them. Probably the easiest way to see them all is to use the more command like this. This shows you one screen full of options and waits for you to request the rest of them. You can scroll the options up one line at a time with the Enter key, or you can scroll the rest of them up with a space bar. This lesson will introduce you to a program named Howdy Window. It's sort of like the Howdy program, but it pops up a window of its own to display text. As you might expect, it's a little more complicated than the Howdy program, but not by much. Here's the Howdy Window program, which I've already written, so you don't have to watch me type. It's only a few lines longer than the simple text Howdy program, but it does use some new concepts, so let me go through it line by line. At the very top, you see two import statements. The only purpose of an import statement is to tell the compiler where to look to find something. In this case, we're going to be using the frame class and the label class inside the program, so the import statement is here to give us the full name of the classes whenever the program refers to them by their simple names. That's all the import statement does, provide the full names for things so the compiler will know where to look for them when you refer to them. The class declaration is the same as before, defining a class with the same name as the file that contains it, but something new has been added. This class extends the frame class. That means that this class is a frame class with some stuff added to it. The stuff added to it is the code in this class definition. It's still a frame class in all respects. It just has some new things added. Just like the Howdy class, this class also has a main method, which means it can be executed by the Java virtual machine. In this example, All the main method does is create a new Howdy window object. The main method is very special, and if you want to, you can think of it as not really being part of the class. It's sort of an entity of its own used to get things started. The new command creates a new object of the Howdy window class. This object will execute to display the window. Notice this method, which has the same name as the class. This is called a constructor. It executes whenever a new object is constructed from the class. A constructor is the only method in a class that is not declared as having a return value. The default return value from a constructor is the address of the new object being created. As we'll see in just a little bit, you'll be able to save the addresses of objects in special locations so they can be used later. In the window we're going to create, we want to display some text. This can be done by inserting a label object into the window. Step 1 is to create a place to store the address of the label object that we're going to create. And that's what this declaration does. Now it's important that you remember that this declaration only creates a storage location. It does not create an actual label object. This is the statement that creates the label object. All objects are created with a new command. This label object is created by passing the constructor the string of text we want it to display, and the address of the new label object is stored in the location that we created earlier. The add method is part of the frame, and you should remember that we are inside a frame object, so the add method can be used to add the newly created label object to the display of the frame window. The frame object has a pack method that you call to have it position all the objects you've added to the window. In this example, there is only one object to be put in the window, so the pack routine doesn't have that much to do, but it still needs to be called so it can position it properly. Finally, the show method of the frame object is called to display the window. And that's it. That's a complete program that can be used to display a window. It runs, but it doesn't do much. In fact, it doesn't even cooperate. In the next lesson, we'll compile this program and run it, and I'll show you what I mean. This lesson is all about compiling and running the very simple windowing program named Howdy Window. Just like any other Java program, it's compiled with the Java compiler this way. Note that it's always necessary to include the Java suffix on the name of the file being compiled. You cannot change the name to any other suffix, but the suffix must always be specified. If there are no errors in the source code, the compiler will immediately produce a class file. The class file will have the same name as the source file, but with the suffix .class. It should be ready to run, which you can do with the Java command. The window appears. Now, we didn't do any sizing or special layout, so the pack routine figured out the size of the label and sized the frame to fit it. Just like any other window, this one can be repositioned and resized. When it's resized, the position of the label is adjusted according to the default layout manager. In upcoming lessons, I'll be showing you how you can control the positioning for both static windows and for windows that allow their sizes to be changed. This window can be minimized and restored just like any other window. It can also be maximized to fill the whole screen. These capabilities are built into the frame object. However, notice that the window cannot be closed. This is the default behavior. It does this because we didn't put in the code to tell the program what to do when the user tries to close it, so it doesn't do anything. I suppose that's a better default than just shutting down and throwing away any data that may have been collected. The program was started from the command line, so it can be stopped there. You send a signal to the program to force it to shut down by holding down the Control key and pressing the letter C. Control C is the ASCII character ETX, which stands for end of text, and tells the program to halt. In future lessons, we'll be looking into adding the ability to have the program halt cleanly. This lesson is all about adding code to the Howdy Window program of the previous lesson to make it possible to close the window with a mouse. The new version of the class is named Howdy by Window, so its source code must be stored in a file by the same name. Starting at the top, two new import statements have been added. Outside information comes into the program in the form of events, and we want to be able to receive the event of the user requesting that the window be closed. The call to the method enable events turns on the window events so they will reach the program. The events arrive in the form of a window event object. The method processWindowEvent is called by the system with the window event object. The window event object is sent for several different reasons. Your program is notified when the window is maximized, minimized, or one of several other things that can be done to the window. This method only responds if the event is the window closing event. That's checked here. The window closing event is checked against the ID of the event coming in as an argument. The window closing event is delivered when the user attempts to close the window from the Windows System menu or from the button in the upper right corner. No change has occurred, nor will it occur with the window. If this program does not explicitly hide or dispose of the window while the processing of the event, the window close operation will never take place. This program, after verifying that it's a window closing event, calls system exit to shut down the program, which also has the effect of closing the window. In a larger program, this method would prompt the user for an option of saving data before closing, or even ask the famous "Are you sure?" question before actually doing anything. Let's see if this works. To do so, the first thing we need to do is compile the program. Then we run the program like this. And the window appears. We can move it and resize it just as we could before. We have two ways of shutting the program down with a mouse. One is to select the system menu on the left, where we can do several different things, one of which is to close the window. Another option, and a more common option, is to use the button in the upper right-hand corner. By selecting this button, the program ends. An event was sent to the program, and the program responded by calling system exit and shut down the program and the window. In later lessons, we'll take a look at shutting down a program from a menu selection and from an exit button. The code to shut down the program is always the same, but the event that comes into the program from outside can be different. In every case, your program is given the opportunity to clean things up before exiting, or to ignore the exit command altogether.